In this video lecture, what we are going to do, we are going to study the part 2 for constructing a quadrilateral. Let us see some other combinations that we need in order to construct a unique quadrilateral. The first one being when two adjacent sides and three angles are known. So, what do we need in order to construct a unique quadrilateral? We need two adjacent sides and three angles. In order to draw the quadrilateral, what do? We first draw a rough sketch and write its dimension along the sides and use the same technique as in when two diagonals and three sides were given. Start with constructing a triangle and then look for the fourth point to complete the quadrilateral. So we are again using the same steps, all the same steps. First of all, making a rough sketch and writing the dimensions, and then using all the steps in order to construct first of all the triangle and then finding the fourth point of the quadrilateral and then completing it. So let's begin. We have this example number 3 and we need to construct a quadrilateral MIST where MI is given to us 3.5 cm, IS is 6.5 cm, angle M is 75 degrees, angle I is 105 degrees and angle S is 120 degrees. So let's first of all just make a rough sketch of how this quadrilateral will be. So MI, I'm going to make a rough sketch. MI given to us 3.5 cm, IS is 6.5 centimeters, angle M is 75 degrees and angle I is 105 and angle S is also given, that is 120 degrees. Something like this. How we will begin? So we are first of all taking a line segment MI that was given to us 3.5 centimeter. So use a ruler, use a scale to draw a line segment MI and that of measurement 3.5 centimeter. Now what do we know? We know that angle M is 75 degree and angle I is 105 degree. You can use a protractor in order to make these angles. So angle I 105 degrees, right? And you can check it this. You can easily make an angle of 105 degrees and this angle is given to be 105 degrees. So first of all, what we made? We made a 90 degree angles and then the half of this 90 and 120 degrees gave us 105 degree. So this is our 105 degrees. That was angle I. You can extend this line and mark this last point as X. Now we will be having the point S somewhere on this line segment. We are given IS to be 6.5 centimeter. So just use I as the center and draw an arc with the radius 6.5 centimeter. With I as the center, draw an arc this is angle 105 degree, right? Starting from 30, 60 and then half will be 90 degree and then half of these two will be 105 degree. You can draw it like this. Now on this extended line IX, taking I as a center, draw an arc of radius 6.5 centimeters and wherever this arc intersects this line segment IX, that point will be our point S. So we have this point as S and IS was 6.5. It is coming to be 6.5, right? This is 6.5 centimeters. Now what do we have to find now? We have M, we have I, we have S. Now the last point that we need to complete our quadrilateral MIST is T. You can check that angle M is given to be 75 degrees. This is 180 degrees, right? A straight line is 180 degrees. This will be 30 degrees and this one will be are 120 degrees. This is going to be 90 degrees, but we need 75 degrees. So taking the half of this 60 and this 90 degree, what are we going to get? We will be getting this angle 75 degrees. So how do we construct it? We go about the linear pair, that is 180 degrees. From 180 degrees we construct one arc for the angle, this angle 60 degrees, and then this angle. And what do? We just take the half of 90 degree and the 60 degree, and we get the angle 75 degree. What was this 75 degree? Angle M was 75 degree. Now from this angle M, passing through this point that we made, draw an extended line. So this is an extended line from M. Now this extended line will have a point T that we need. We'll be having the point T on somewhere on this extended line. What are we given next? 3.5, 6.5 we have used, angle M 75 degrees we have used. Now this 105 degrees we have made. Now S is given to be 120 degrees. Now from S, construct or draw an angle 120 degree. It can easily be made from 60, and then double of 60 will be at 120 degrees. So from S as a center, we are now going to draw, by taking S as the center, we are now going to draw the angle having measurement how much? 120 degrees. So from S, draw an angle. This will be 120 degrees, this arc. Right? So this, because this was 90, this is 120, right? So this is our 120 degrees, and extend this line. When we extend this line and meet it with this MZ line segment, the point where both of these SY and MZ are going to intersect, that point is going to be our point T. So this angle 120 degree angle S, and this point of intersection is going to be our angle T. Now you can see that MIST, our quadrilateral, has been completed. So this is how we followed all the steps, starting from a line segment, constructing all the angles that are given to us, and then further on we used all the line segments, made all those and extended those line segments, and then we saw where those line segments were intersecting. The point of intersection were the vertices of our quadrilateral. We have a brainstorming question. Can you construct the above quadrilateral MIST? See this quadrilateral again, MIST quadrilateral, if we have 100 degrees at M and instead of 75 degrees. So it said that instead of 75 degrees at M, if we had 100 degrees at M, then was this quadrilateral possible? The answer will be, just think of this, from 75 degrees, if we increase this angle's measurement till 100 degrees at M, will this quadrilateral then be completed, or will this be constructed? Yes, this will be possible, because in that case, still the angle sum property of quadrilaterals, that is the interior angle, the sum of all the interior angle of a quadrilateral should be 360 degrees, is still there verified. Therefore, we can say that yes, this quadrilateral MIST can still be constructed if we had 100 degrees angle at M instead of 75 degrees. But just in that case, angle T's measurement will change, because vertex T will then, if it is 100 degrees, then T vertex will go to somewhere other place and T angle will also change. But still we will get a quadrilateral MIST. Another brainstorming question that we have is, can you construct the quadrilateral plan PLAN? Now what is given to us? If PL is 6 centimeters, LA 9.5 centimeters, angle P is 75 degrees, angle L is 150 degrees, and angle A is 140 degrees. So see, all these things are given to us, and hint is also given to us that recall the angle sum property. See, we have a quadrilateral plan, we have angle as 150 degrees, angle A as 140 degrees, angle P as 75 degrees. This is going to be how much? 365 degrees. So just the sum of three interior angles of this quadrilateral plan that is given to us is going to be 365 degrees. But we still had to have some other angle for the angle N. We are not provided with angle N, but the sum of only the three interior angles is exceeding 360 degrees. So this is not possible because the angle sum property, what does it states? The angle sum property of a quadrilateral states that the sum of all the interior angles of a quadrilateral should be 360 degrees. And this is not verified here, so we can say that we cannot construct such a quadrilateral plan, PLAN. Next one is, in a parallelogram, the length of adjacent sides are known. Do we still need measure of the angles to construct as in the example above? So what are we given? We have been provided with, say we have been provided with the lengths of the adjacent sides. We have a parallelogram, say this ABCD. What are we provided? We are provided with the length of the adjacent sides. So say we have AD and we also have DC. We have these two sides. Do we still need measure of the angles to construct as in the above example? Yes, the answer will be yes, because for such a combination, to be able to make a unique parallelogram in this case, we need at least the measure of the angle that is included. That is, in this case, we at least need the measure of the angle D, the angle that is included between those two adjacent sides in order to construct a unique quadrilateral. So in this case, we still need at least the measurement of at least the angle that is between these two adjacent sides. And then we can make a quadrilateral, the parallelogram. Next combination is that of when three sides and two included angles are given. So what are we given now? Now we are given three sides and two included angles, the angles that are included in those three sides. So in order to draw the quadrilateral, we first draw a rough sketch. In every condition, we are going to first draw a rough sketch that is going to give us some idea about the quadrilateral. Write its angles along the sides, use the same technique as in when three angles and two adjacent sides were given. When you draw a rough sketch, note carefully the included angles in particular. Yes. So we need to note carefully that the included angles in particular, right? Which are the included angles that are given to us? We need the two included angles in such a case. So what are all the steps that we are going to follow now? We will still begin with constructing a rough sketch and then writing all the angles, all the sides that are provided to us, the measurements, and then bringing on and then drawing all the necessary vertices of the quadrilateral and completing it. We have an example number 4 based on this. We're given construct a quadrilateral ABCD. Now AB is given to be 4 cm, BC we have 5 cm, CD we have 6.5 cm, and two angles that are B and C are given to be 105 degrees and 80 degrees respectively. Now see that the rough sketch of this is going to be somewhat like, see, AB, that is 4 centimeters, BC, and B is 105 degrees, so it will go somewhere here. BC is 5 centimeters. This is 105 degree given to us. Angle C is 80 degrees. So this is going to be somewhere like this, 80 degrees. We have this as 4, we have this as 5, and CD is also given to be, this is 6.5 centimeters. So our quadrilateral, this is the rough sketch that I made of this quadrilateral ABCD. Now we'll begin. So we are going to construct, first of all, a line segment BC that is provided to us. Use a ruler or a scale, in order to draw that line segment, and its measure is given to be 5 centimeters. So draw BC, 5 centimeters long. Now from C, we are given the angle to be 80 degrees. Construct an angle 80 degree that is going to be lesser than 10 degrees lesser than the 90 degree right angle. Use a protractor. You can construct the angle C here. Extend this line. We are given CD to be just extend this line from C, extending this line from C. Now we are given CD to be 6.5 centimeter. Use C as your center and draw an arc of radius 6.5 centimeter. And the point where that arc is going to intersect this extended line from C, that point will be our D point. So this is CY, the extended line. Now, okay, yes, we can still begin from angle B. So we can still proceed from angle B now. Angle B is given to be 105 degrees. So this is our 180 degrees, and this will be our 90 degree. 105 is going to be in between this 90 degrees and 120 degrees. So you can construct it easily. From this 90 degree, you first of all made all these arcs for angle 60 degree, angle 120 degree, and then you took the middle point of these two, and you got the 90 degree angle, the right angle. Now the middle point, at the center, what are you going to get? You're going to get from the center of 90 degrees and 120 degrees, you're going to get the angle 105 degree, and that was our angle B. So you can easily construct the angle here. Angle B, you can draw it as 105 degree, this angle. Now draw a line from B extending and passing through this point. Extend it, call it as BX. This is an extended line from B. This angle is 105 degrees. That was given to us. See here, it was given to be 105 degrees. Now the next is that we are given AB to be 4 centimeters. We are given AB, that is 4 centimeters. Now this is an extended line. Use B as the center and draw an arc of radius 4 centimeter on this extended line. And the point where this extended line and the arc are intersecting, that point is going to be our point A, our vertex A. That will be of 4 centimeters. So you can say that this is our point A, and it is of this AB line segment is of 4 centimeters. Similarly, in the case of CY that I told you earlier also, you're going to construct a line of 6.5 centimeters. 6.5, take the center as C, draw an arc of 6.5 radius. The point where this arc is cutting this line segment or passing through this line segment, the point of intersection is going to be our point D. It will be of CD will be of 6.5 centimeter. Now the last step that we are left is to join AD in order to complete this whole quadrilateral ABCD. So we just join vertex A with vertex D, and we get our whole quadrilateral, the complete quadrilateral ABCD. This is example number 4. Now there are some special cases also. To draw a quadrilateral, I told you that we require 5 measurements. Right? We require 5 measurements in order to draw a quadrilateral. But is there any quadrilateral which can be drawn with less number of available measurements? Will there be any quadrilateral that can still be drawn uniquely with lesser than 5 measurements? So the answer to this is yes. Yes, we can draw a quadrilateral with less number of available measurements if some special property for the quadrilateral are known. Only in the case where we know some of the special properties for that quadrilateral, we can still construct it uniquely when we are well known of the special properties of that quadrilateral. We're given an example like for square. We know that for a square, all sides are equal, or we can say that all the angles are also 90 degrees. We can easily construct it even if we are given lesser than 5 measurements. See, we have an example number 5. We need to construct a square, and we are only given the side of the square. Only one side of the square, that is 4.5 centimeters. So the thought that first of all should strike your mind is that for a square, we know that the property of the square is that all the sides are equal. So we can say that we have the measurement of all the 4 sides. We know all the 4 sides of the square is going to be 4.5 centimeter if one of the sides is 4.5 centimeter. Now we know one more thing, that all the angles are also going to be 90 degree for the square. We can construct now because we have got more than 5 measurements we can say. First of all, draw a line. you will follow all the same steps, drawing a line, using a ruler or scale of 4.5 centimeter, that will be AB. Then construct an angle of 90 degrees on A as well as on B. This will be 60, 120. Just follow all the same steps. Halfway middle will be 90 degrees. Now again, this arc is made from A, taking center as A, but this arc is of radius how much? It is going to be of radius 4.5 centimeter, because AD side is also going to be 4.5 centimeter. So taking A as the center, draw an arc of radius 4.5 centimeter, and the point where this arc is going to intersect this extended line, that point is going to be our point vertex T for that square. This will be 4.5 centimeter. Now do all these similar steps on vertex B also. Draw an angle 90 degrees, extend this line, again draw the arc of radius 4.5 centimeter, taking B as the center. This will be our vertex C. At last join C and D, and you will get your whole square ABCD. So we have now concluded that through this example that yes, even if we have lesser than 5 measurements, but we know that the case is special, that we already know some of the special properties of that quadrilateral, we can still construct a unique quadrilateral. Like in this case, we knew the properties of a square. This is our square. One more example we have, example number 6. Is it possible to construct a rhombus ABCD where AC is equal to 6 cm and BD is equal to 7 cm? We need to justify our answer also. So now we have a rhombus ABCD. We're given AC as 6 cm and BD as 7 cm. So what all properties do we know? For a rhombus, yes, we can construct it, and let's start constructing it using all these similar steps. So from A, we are given AC. Using a scale, you can draw line AC 6 cm. Now AC is a diagonal, BD is also the diagonal. These two are the diagonals of that rhombus. These two are the diagonals. One is AC, that is 6 cm. We have constructed it using a scale 6 cm AC. Now for BD, draw a line, and that line will be BD. So this BD will be of 7 centimeters. How can we construct this BD? We can construct it easily using the property of rhombus, that its diagonals, they intersect at 90 degrees. At how much angle they intersect? We know that the diagonals of a rhombus, they intersect at 90 degrees. So how we are going to proceed? We are going to proceed by taking that this angle will be 90 degree. And where are we going to make the point of intersection for these two diagonals? We already know. We know some other property of rhombus also, and that is that both the diagonals, they are the bisectors also. They are actually the perpendicular bisectors. That they have right angles between them and they bisect each other. They divide each other into equal halves. So 6 centimeters half will be 3 centimeters. So this is going to be 3 centimeter, right? So from A, take 3 centimeter on C, and on that 3 centimeter, like the midway of 6 centimeter line, draw at 90 degrees, draw one more line. That is going to be our BD. This point of intersection, their point of intersection is going to be O. Now this BD point, extend this line that you have constructed it from the middle of AC. Extend this line, but in order to make B and D vertices, we know that BD, the full BD's length is given to be 7 centimeters. So at what point the diagonal will be intersecting it? At halfway middle. That is half of 7 centimeters, that is 3.5 centimeters. 3.5 centimeters from here and 3.5 centimeters from here. So from O, taking O as the center, draw an arc of radius 3.5 centimeters on this side. And similarly draw an arc of 3.5 centimeters, taking O as your center on this line, this side of the line. Call this point as your vertex B. On this side also, call this point as your vertex T. Now just join. These are going to be 3.5 centimeters as I already told, because it is going to be half of the diagonal BD. because we know that the diagonals of a rhombus are perpendicular bisector of each other. Now what do we need to do? In order to complete this whole rhombus ABCD, we just need to now join all those points, all the vertices A, B, and C and D. So you can see that this is the required rhombus ABCD. We can conclude that again now in this example also we only had two measurements given, and those were the diagonals. But we knew that the given quadrilateral is a rhombus and it has some special properties. And the properties that we required here, properties that we used to construct this rhombus ABCD, were that both the diagonals, they bisect each other, and both the diagonals bisect at 90 degrees. That is, both the diagonals of a rhombus, they are perpendicular bisectors of each other. So this was the property that we used. Now we need to try these. How will you construct a rectangle PQRS if you know only the lengths of PQ and QR? So is it possible to construct a rectangle? Focus here that we are given a rectangle PQRS. So is it possible to construct a rectangle PQRS if we only know what? If we only know PQ and QR. You can see PQRS is going to be a quadrilateral. Can be constructed if we only know PQ and QR. Just think of it. This is a rectangle. So we can say yes, we can construct this rectangle. We can construct it easily if we only know PQ and QR and no other measurements, because for a rectangle we know that the opposite sides will be equal. So if we know PQ, that is going to be same as SR. If this is X, this will be X. If we know QR, that is Y, that is going to be same as PS. That will be also Y. So we have got the four sides, measurement of all the four sides. Now we know some other thing as well for a rectangle, that all the angles are again going to be 90 degrees. So we know more than 5 measurements. You can say that not only 2 measurements, but we know at least 5 measurements here. So we can easily construct this rectangle PQRS and following all these same steps, you can do it. Now we have this question to try, and in this question we need to construct a kite EASY easy, and we're given the measurements of AY, EY and SY. We are further asked that which properties of the kite did we use in this process. So even if we are given lesser than 5 measurements, we know that this is a special quadrilateral that is provided to us. This is a kite, so it's very important first of all that you focus on what type of quadrilateral is given to you, especially in those cases where we are given lesser than 5 measurements. Like in this case, we are given the type of quadrilateral here is kite. We know some of the special properties for a kite. So those are the properties that we are going to use in this process. We can easily construct it. Now this is going to be that kite that is required, EASY. You will construct it yourself. I'll tell you that what all properties you require. So it will look like something like this. And after joining all these vertices, you will get your kite EASY. What are the properties that we used while constructing this kite? The property that the diagonals, one of the diagonals is going to bisect the other diagonal. Right? The other property that the diagonals will be at 90 degrees to each other, perpendicular. And the third property that is going to be that our adjacent sides. These adjacent sides are going to be equal. So our adjacent sides are equal. They are given if we are given one side, EY. You can find the adjacent side to it. If we are given SY, you can find the adjacent side to it. Those will be equal. So the adjacent sides are equal for a kite. The diagonals are at 90 degrees and one of the diagonal bisect the other diagonal. These are the 3 properties that you required in order to construct this kite easy. You can construct it yourself just following all the steps that we did earlier also. So this was all about our video lecture 3. In the next video, we are going to do a quick revision for all these concepts. We'll meet in the next video. Till then, bye bye.